Hello guys, I am M. Harshit Reddy, a third year electrical engineering student from IIT Tirupati. Today I am going to present a research paper on the Mish activation function. Okay, so let's dive into it. Okay, some of the things that we're going to look at today include uh, the basic introduction of activation functions and how is Mish different than the other activation functions and the perform and some of the characteristics of the Mish activation function. And we're also going to look at the performance of Mish with the other activation functions like let's say a rectified linear fluid and a leaky residue or sigma damage and other activation functions like that. Okay, so let's start our discovery. So basically, to start off, activation functions are often the unsung heroes of deep learning. They don't grab the headlines like the ResNet model or GPT, but they inside the neural network, they decide how the model learns, generalizes, and performs. Today, we're going to explore one of the most promising activation functions yet, which is called Mish, which is smooth, stable, self-regularized, and surprisingly powerful. Okay, so let's first understand why do we even need activating functions in the first place. So neural networks without activating functions are like stacks of glass. So no matter how many you add, you still see a straight line. So activation functions basically introduce a sort of uh, non-regularity. Uh, they introduce curves and non-linearity that help our models capture the real world, understand patterns and sentiment, and classify objects and such. They activation functions really help us classify things, which help us do our functions very easily. So that is a bit about activation functions, and you can look at the many of the famous activation functions we got to use in the presentation. And let us understand what the limitations of these activation functions are. So sigmoid and activation functions like sigmoid and tangent were the early favorites, but they do saturate the derivatives of these functions. What happens is the derivations of these functions, as the input gets too large or too small, the derivatives of these functions vanish. So what happens is while we iterate the inputs, the iterations keep on, we get this, as the derivatives vanish, we get the same values as we iterate the input. So there's no learning as such. Uh, so there's no gradient descent and the learning stops. Then rectified linear unit was introduced, which is simple and fast, but it has a fatal flaw that the negative inputs become zero. And like basically once a neuron in output zero long enough, it dies. This function is called, this phenomenon is called dying value function. So that's why there was a need of a new activation function which is more efficient for user required. So we're going to see how did people come up with various solutions. So to fix Relu's shortcomings, Google introduced Swish, which was the function of Swish is x times sigmoid of x, like x into sigmoid of x. Swish function was smooth, flexible, and performed better than Relu in deep architectures. But then we had but then Professor named Diganta Mishra introduced an activation function named Mish. Mish blended the smoothness of Swish and with even better regularization gradient flow. It discovered it was it wasn't discovered by a huge tech company, but it was discovered by a Tirupati researcher named Vedanta Mish. The formula of Swish is x into tan of soft plus x function of x. Yeah, we don't see that. Okay, let's look at the formula of x. It is x into tan h of soft plus function of x. This creates a function that is smooth, continuous, and non-monotonic, meaning it curves slightly downward before going up, which really helps capture the negative inputs and the positive inputs and the derivative. Everything is smooth and better than the other activation functions. So we're going to look at why Mish works so well. We're going to look now why Mish works so well with the other activation functions. So basically, uh, So, why Mish so well? Why Mish acquisition function works so well is that unlike a random, which discards anything below zero, which keeps the small negative values. This means that your neurons still get to learn from subtle nuanced features instead of being silenced. Also, because Mish is smooth with no sharp corners, it makes the gradient descent feel like heading on a freshly paved highway. So, basically, to give you a real world analogy, the railway is a staircase and English is a glide. So there are many ups and downs in a staircase, while a glide is smooth and really efficient flow. So that's why mesh works so well as compared to the other activation functions, as you can look at the graph. So let us now look at the performance of mesh in various data sets. So basically, let's get to the numbers. Mesh has been tested across popular benchmarks like CIFAR, CIFAR 30, ImageNet, and MS4, the which are some of the famous data sets for image segmentation and uh, image processing. So in these, the results showed a consistent performance boost over both value and mesh. In some cases, a 1 to 3% accuracy gain and in object detection tasks up to 2.1% high precision. So the bottom line is you can change one line of your code with the emission function and and your model starts performing better with no extra layers or medium. So that is about the performance of mesh with other activation functions. And now let's get to uh, the self-regularization function of mesh. It is one of the characteristics of the mesh activation function. So, one of the most, in my opinion, one of the most exciting aspects of the mesh is something called self-regulation. Most models need help to avoid overfitting. We need something like a dropout, a batch norm, or a weight decay. But when it comes to mesh, it way it regularize it in how to say it incorporates regularization into itself into its shape. Its curve penalizes extreme outputs and encourages smooth gradients. So, like to give you a real world analogy, it's like uh, it's like a musician uh, singing with his own voice without the need of any conductor yelling tempo or pitch. That is mesh. Just explain what design. Okay, so now let's look at one limitation of the mesh activation function. Uh, so, but as we've already talked about, the mesh function is very elegant, but it comes at a cost. The formula includes damage function and the soft plus function, which are a bit complicated as compared to the ReLU function, uh, which are obviously straightforward. So to overcome this complicatedness of the mesh function, there was another extension of the mesh function called the mesh CUDA function, which came in, which was it. Mesh CUDA is a GPU optimized implementation that brings speed to the table. In the performance tests, as you can also look at this presentation, Mish Kuda ran nearly as fast as the ReLU function and more than 3x. As you can see, it ran almost 3x faster than the original Mish function. So When you use this mesh coda function, in other words, you get all the smooth learning benefits with none of the drag, none of the limitations. So that is my presentation of the mesh function and why mesh activation companies are actually. Thank you. I'm Harsh. I'm Harsh.